Okay, sorry for these technical issues, and good afternoon, everyone. I'm glad to see many of you connected again, and welcome to this cycle of inspiring seminars for this PhD program in aerospace science and engineering at Politecnico di Bari. I'm sorry, as I said, for the technical issues, and I really understand that now that we are starting to recover the normal uses to meet in person and also make lessons and examination in person, it's a little bit difficult to be connected in this telematic mode. So thanks for being here, and sorry again. So today we have the opportunity to host Dr. Cristoforo Abbattista. He's head of SpaceStream Strategic Business Unit in Planetek Italia, but he is also a former student of Politecnico di Bari, a good friend, and let me say, a famous volleyball player. You have to know that. So Cristoforo's talk will be on Spacedge, turning flying boxes into proactive collaborators. And this is indeed a very interesting topic. I'm pleased to welcome Cristoforo, and I really thank him for his kind availability. Today's talk will be moderated by Dino Guaragnella, who is a professor of telecommunications at Politecnico di Bari. But first, I would like to pass the word to Francesco Cupertino, our rector, for a welcome greeting. Thank you.
Thank you, Marco. I would like to welcome all of you to this new event of the program dedicated to inspiring speeches, as Marco said, on aerospace technology, entitled Rediscovering the Space. And when we designed the overall program, but also when we started thinking about the PhD program in aerospace science and engineering with the University of Bari, we stressed our attention on the diversity of possible scientific technical contributions. In this cycle of seminars, contributions are coming from different experiences, ranging from private companies, research centers, and of course, universities. I'm convinced that in the next future, the space will have an impact on our life. Many services will be given using data coming from the space, from satellites. We have to decide whether we want to wait until other people do the job and then be the users of such services, or we may try to give a contribution to build our future, to play a role, to write the screenplay. It will be important not in this context to act like single entities, but to act as a system. In our region, we are lucky. We have universities, we have research groups, and we have companies with a worldwide reputation in this field. Our success will be determined by our ability to collaborate with the other players already active in the field of aerospace, but also to collaborate with researchers and companies coming from other fields. As we will listen in a few minutes directly from Cristoforo Abbattista, competencies and technologies needed to add value to the data coming from the space are many, are diverse, and coming from different fields. This could represent an opportunity for researchers, entrepreneurs, and companies. We are trying to do with this, with our dissemination activities in general, and also with this cycle of seminars, to create a condition that will give us the possibility in Apulia to make such opportunities, to add value, to exploit such opportunities, and let them becoming jobs, opportunity, and growth for our country, for our territory. I hope that the initiative Rediscovering the Space, and in particular today's speech, will be of real inspiration for all of you. I sincerely thank Cristoforo Abbattista for his kind availability, and Planetek for the collaboration and the friendship with the Politecnico di Bari. And I give the floor to Professor Guaragnella, who will act as a moderator of this seminar. Thank you all.
Thank you very much, Francesco, and thank you very much, Marco, for the opportunity you're giving me to chair this webinar. And a special thank to Planetek for accepting the invitation to this seminar. As everybody of us should know, Planetek is an Italian company established in 1994, and its core business is centered on design of new processes and solutions to be used for geolocalized information to generate knowledge. Often we are inclined to think that space is something that can be considered like a game for researchers, and that research may produce low impact results on everyday life. And the talk today aims to confute this belief. It is my pleasure to introduce and thank Cristoforo Abbattista for being here today. Let me give a few notes on his career. Cristoforo Abbattista is the head of SpaceStream Strategic Business Unit in Planetek Italia. He received a master's degree in electronic engineering from Planetek Italia in 1997, working on image and signal processing. After working for Exprivia, the National Research Council, and Accenture, he joined Planetek Italia in 2002. And from 2012 is the head of SpaceStream Strategic Business Unit, whose main activities are related to the design and development of software for the value chain of space system, from onboard software to ground system deployment and Earth observation. He is co-author of several publications in the field of satellite system and spatial data infrastructures. And since 2009, Cristoforo has been also a lecturer in IUAV University in Venice. Today, we are proud to welcome him at Politecnico di Bari. The talk he is going to give has the title Spacedge, Turning Flying Boxes into Proactive Collaborators. A challenging and very interesting topic, and mainly a new business scenario. So, Cristoforo, please let us know what are these flying boxes.
Yeah. Good afternoon, everybody. Thank you, Dino, for your kind introduction, and also thank you, Francesco and Marco, for your invitation. I'm very proud to be here and honored to be here because, as you said, I was an engineer from Politecnico of Bari, and so after 30 years, I'm coming again to try to teach something about our experience, to say something about our experience, and also to say something about our vision, our roadmap for the space activities. I think that what you have already said, Francesco, about the fact that we need to reason as a system of system and ecosystem will be also shown by my presentation, and that it's totally related to the fact that we do not need anymore only one flying boxes. We need several flying boxes, and we need also that they need to be connected to each other. So I'm very honored to try to say something to you about our roadmap. I want to go to share my presentation. I prepared this presentation, so please confirm that you can see it.
Yes,
okay,
it is visible. Yes. Thank you.
Okay, I'm going only to. Okay. As you were saying, the title of my presentation is Spacedge. You know, the edge is the capability to process data at the edge of an infrastructure. So not only in a centralized way, but the capability to process the data when they are sensed or acquired by different kind of sensors. In this case, we want to stress the fact that the sensors are in the space. Typically, they are satellites, and the flying boxes, of course, are the satellites we are going to speak of. So we want to make them our proactive collaborator, because until today we can say that all the flying boxes are passive workers and not proactive collaborator, and we want to be them more proactive for us. To do that, I will give you also a vision and an overview of the path of the roadmap that Planetek has followed from the starting of its activity, going from remote sensing to SpaceStream. Just let me understand. Okay. This is the statement that every day when we enter our company we see on the wall. Non ci sono passeggeri sulla nave spaziale Terra, siamo tutti parte dell'equipaggio. There are no passengers on spaceship Earth. We are all crew. And this statement represents very well the mission that in Planetek we have. We want to take care of the Earth, and we think that the space is one of the most useful places to take care of the Earth. Only a few words about Planetek. Planetek, as already said, is a small and medium enterprise based in Bari, and we have also a sister company based in Athens, and we participate 2 spin-offs, one from University of Bari, GAP, and one from University of Tor Vergata. We are something like 65 people in Italy, in Planetek Italia, and 25 people in Athens. We started our business in 1994, and this year we became also a benefit company. It does not mean that we are a no-profit company. We are for profit, of course. We are a private company for profit, but we want to demonstrate that the goal of a company is not only profit. We can reach other goals, and in particular, a benefit company want to sustain the environment and the landscape, territorial landscape, and so the society in which the company is immersed. So we want to return to the society in which we are some values, demonstrating that we can increase the culture. Of course, in this case, we are speaking about even of technical culture, even about environmental values culture, but even simply by sponsoring some particular event that could be linked to this attention to the environment or to the society. As a company, we are divided in 3 business units. As said, I'm the head of SpaceStream business unit, and we have also other 2 business units, one totally addressed to the institutional market, government and security, and the other to the private market. In these 2 last business units, we sell services based on Earth observation data. And essentially, we do the same thing, but different with a different customization because of the needs of the different market. And you can recognize that we address market like oil and gas, energy, infrastructure monitoring, or environmental monitoring, defense and cyber protection. A little bit different is the business unit SpaceStream, because we not only develop some experimental Earth observation services and application, but we also develop some system and software for the total value chain of the space. That is, we develop software for onboard, to be embarked on board of satellite, software to be installed in the midstream of and we will recognize what is midstream, in the ground station, let's say, software to process also the first data acquired by the satellite, and finally software for the downstream services, let's say the services for environmental monitoring, energy monitoring, infrastructure monitoring, and so on. Of course, everything we do for the Earth, we do also for scientific mission, and we have embarked, for example, our software on board of Solar Orbiter satellite. I want to show you also this slide only to let you understand that from the beginning of our business, we started our collaboration with the satellite data provider. And here you can see that essentially we have always sold all the data acquired by the satellite, and we have different agreement with the different data provider. So it is part of our business, but of course we don't want only to sell data. We want to add value to such kind of data. So what are we speaking about? Here you can see, I hope, a video describing what is the population of satellite around the Earth. And you can see a big circle, and now you can recognize that big circle. In that big circle, there are the geosynchronous satellite, geostationary satellite at 36,000 kilometers from the Earth. While then you see another big crowd at very close to the Earth. They are what we call low Earth orbit, and it seems that the space is very crowded. Really is not so crowded as you can see from this animation, because the satellites are not so big, but we can say that we are going to have a more and more crowded space. Actually, we have something like 3,372 satellites orbiting the Earth. And if we give a look to some number, we can see that an half of those are managed by United States company. Then there is an half of these for the rest of the world, and so China and Russia. In the rest of the world, there is also Europe as, again, an half of this number. So something like 500, 400 satellites are managed by European company. Most of these satellites are, of course, for the telecommunication, let's say an half of those, and the rest is for Earth observation, let's say remote sensing. So they embark something useful for capture signal from the Earth, emitted or reflected, and only a few of them, less than 50, yeah, something like 50, are related to navigation satellites, so Galileo, GPS, GLONASS, and so on. If we give a look to a historical map, we can see that in 1966, only a few countries had the capability to launch or to operate satellite, while today practically all the world can launch satellite or can manage satellite or can buy and manage satellite. So mostly this is due to the fact that while in the past only very, very big satellites were launched, today we have arrived to launch satellites that have a weight less than 1 kilo. So here is a taxonomy of what we call the large, medium, and small satellite. And among the small satellites, we can recognize picosatellite, nanosatellite, and in and half of the satellites actually orbiting the Earth is of these size. Let's say 110, in reality 120 kilo. So this is the difference. So on the left, you can see an satellite from ESA, and 8 tons satellite. It embarked something like 12 instrument sensors able to capture information coming from the Earth in different modes and in different part of the electromagnetic spectrum. While on the right, you can see a colleague of mine having in his hand not a model, but the real size satellite. Of course, it is not the real satellite, but in real size of planet. It is a 3U satellite. It means 30 by 1 by 10 by 10 centimeters satellite, like a shoebox, and its weight is something like 3 kilo. And so we can see here that we have 1,700 CubeSat orbiting or nanosat orbiting the Earth in 2021. for 3,050 and 500 units. It means that there is a medium of 2 units per satellite. Even if today we can say that the standard size of the CubeSat is that of 3U, 6U, and we know also some CubeSat arriving to 24U. So we are speaking about 24 kilo or something like that. But as you can see, the most of these satellites are very, very small. Here, there is a video showing how they are deployed in the Earth. You can recognize the format. We can do that by using some facility that are embarked on International Space Station, or simply we can put them into some deployer that are then embarked on board of rocket. So while in the first case the Soyuz take the CubeSat on board of the ISS, in this case, and we are speaking of the Ion deployer by a friend of our company, the Orbit, that can embark into the deployer until to 48 units, and typically these 48 units correspond to CubeSat 3x1 of 3 units. So we have 16 CubeSat that could be deployed by the deployer. So the deployer Ion is embarked on board a rocket, then it is launched by the rocket, and the deployer arrives to the orbit in which each customer wants to be deployed by its satellite, for its satellite. And so we can say that to arrive to the final orbit, the CubeSat don't need to use propellant. Nevertheless, they need to have some actuators because they need to maintain, then after releasing, they need to maintain their orbit, they need to maintain their attitude, and so they need to perform some maneuver. But why we launch satellite? Here you can see some pictures that typically we show to let understand the quality of the information that we can derive from space. And for example, here are some digital globe images, and it's clear that we can perform intelligence about some territory. And for example, we can count the container, we can understand how many ships are in the harbor. We can understand also if the container are moved or not during the time, and so on. And we can arrive today at 30 centimeters of resolution. It means that in the visible spectrum, like this picture, we can identify details around 30 centimeters. Again, we can use such information for intelligence application. In this case, we are able to understand that it can be used from defense, for example, because we see some checkpoint, we see some track, and so it can be this kind of information can be used even for counterterrorism or other activities like that. Or for the security of people. Here you can see in the yellow line signing the border of a country, and you can see that we have some migrants that want to pass the border. So for border security application, it could be very interesting. Consider that we can get this information because the satellite have been tasked from ground. So we have the information after we know that something is happening. Consider this because, and remember this, because we want to overcome this fact. And again, for infrastructure monitoring, this is Fukushima after the nuclear disaster. And again, we had the disaster, and then we tasked satellite. or we want to monitor the evolution of the building of a stadium. We did it for the Expo 2015, for example, for Milan. And thanks to constellation, and here you can see in the top right the Dove satellite. So thanks to constellation like those of this small, very small satellite, 30 centimeters by 10 by 10, we can even monitor the situation of this port every day. So thanks to the fact that they have deployed 200 similar and equal satellites, we can have a picture of each part of the world every day. And in fact, we can see the changing of the changing of the situation in this port. And so in particular, we can see ships going on and from this part. Sorry. And of course, we use satellites to manage for environmental monitoring, and typical to react to some problem caused by weather, by flooding, and so on. But you know, when there is a problem with the weather, typically we have clouds. So when we need satellite, we cannot see under the clouds. And so we invented something like radar many years ago. And today we are able also to see under the clouds. We can see under the cloud because we use microwaves that pass through the clouds and reflect. So it is what we call active satellite, reflect the situation that we see under the cloud and so on the ground. And after having such kind of information that you can see it is a monochromatic information because it is the interpretation of a signal, we can realize that maybe a part of the territory has been flooded by raining. And so we can merge together with other information and understand that there are some problems. In this case, you can see that a part of the city is under water, very probably. And we can even collect videos from the space. Typically, these videos last for less than 1 minute. You can see that it is a video because you see cars moving. This is a video from satellite. There are also videos from International Space Station. And you can also realize that it is a video from the plane that was before flying, or from the big and the taller buildings that change their attitude respect to the satellite. Really, to get this kind of video, we need to process all the frames that are collected, because here the satellite is changing its attitude towards the Earth. So in order to have all the videos, all the frames registered each other, we need to process them. And in fact, you see that the roads don't change their position in the video. We have also the capability to see planet during the night, and here you can see some images coming from a Chinese satellite. It is important for counting or for monitoring the situation of public illumination, but you know, maybe there are other sensors to do that. Anyway, we know that the amount of light coming from the Earth, it's a good indicator also to measure the quality of life in that place. So the more you have light, more probably you have a good quality of life. And again, we can also see the Earth in different spectral bands. Here you can see some pictures coming from the Prisma Italian satellite, which is the only one operational satellite able to get information in different spectral band. Prisma catch energy in the band of visible and near infrared and middle infrared, and we have something like 240 bands at 30-meter resolution. The most important characteristic of an hyperspectral satellite is the capability to provide what we call spectral signature. It means that for each microband of 10 nanometer, we can have the quantity of energy that was spread from a pixel of 30 by 30. And so we can even try to understand the materials that are under that pixel and the contribution of different material to those pixels. Okay, so we have seen that we can get a lot of images from space, a lot of information, more than or better, a lot of data from space, and we have realized that most of what I have shown to you is for visual inspection, is for mapping, classification, but we know that our customers don't want maps, don't want data, they want the information. And so some years ago, we started our first step toward the Earth intelligence, what we call the Earth intelligence, more than Earth observation, and by realizing Reticus. Reticus was the only pupil of Copernicus. And so after European Commission started one of the two main programs, space program, the other one is Galileo, and the first one is Copernicus for Earth observation. We realized that we could call Reticus our software, because our system, because we want to exploit all the capability of Copernicus by its pupil, Reticus. And in fact, we know the life of and the discovery of Copernicus thanks to Reticus, who wrote all the life of Copernicus. So our customers don't want maps, they want number, they want information supporting their everyday job, information that can be put into their everyday workflow, job workflow. So we realize, we call them analytics. In this case, we are speaking about geoanalytics. And in order to let you understand what we mean, they could be classified into three main classes. Descriptive analytics. It means that thanks to the fact that you can see what is happening on the Earth, you can even describe what is the situation in terms of number. For example, you have 100 square kilometers of buildings of sealed, you have 200, and so you can put this number and you are describing what is the situation. But you could also say something more to the customer. You can use what we call a predictive analytics. So what will happen if nothing is done by you? So this is the situation, and if you don't do anything, oh sorry, I have we are time. Just a minute. I forgot to do that before. Sorry, we are from a long time on WebEx, so I forgot to put my battery. And I was saying about predictive analytics, what the situation will become if you do nothing, or prescriptive analytics, what you should do to get different results from what is predicted. Here you can see some pillars, some applications, some like utilities, engineering, food, and I'm going to show you some of these applications to let you understand what is the roadmap. Of course, our customers are not interested in maps, and of course they are not interested in which kind of satellite data you use. So we use all the satellite data that are available. And in the top, you can see the Copernicus satellite, whose name is Sentinel. On the left, you can see commercial satellite that, differently from Copernicus, are not for free, so you need to pay, and you can have, of course, different characteristics available from the Sentinel-1, and on the left, other kind of satellite like those of Planetek, commercial satellite, commercial data that could be used for other applications. So according to the application, you need to understand how to address that application and which are the best data that you can use. And in fact, at the beginning, we called Reticus also Data Fusion Center. Here are some applications that you can see in the form of a video, in the form of a picture, for example, application to monitor wildfires. And after the processing of the satellite data, we are able to provide to our customers a report that does not speak about maps, but only about the amount of the land that was fired. And for old fire, what is the ongoing situation? Because, you know, we have some laws that forbid to build on top of a burnt area and so on. So again, I want to stress the fact that we are going from the maps, from the classification that you can see here to the report that you have seen. Other application like agricultural application, again the same. It's useful to understand what is the level of maturity of, in this case, of grapes, and if it is important to harvest or not. Is useful to harvest or not your culture. I want to say that agriculture in Italy is, for agriculture, is not so simple to use satellite data, because we know that farmers know very well their trees, so they don't need our help to understand if they have to harvest or not. But there is a but. We are in a period in which we are aware of the fact that climate changing is changing also the behavior and the characteristic of our culture. So there are some other information that cannot be related to our experience. And so it's important, it's starting to be important to monitor, to measure this information to help the farmer in understanding the situation. The same happened, for example, for aquaculture. In this case, we have services to let farmers understand if it could be useful or not to harvest mussels or to take fishes. Okay, they should know when is the period, but they cannot monitor the sea surface temperature, for example. And so maybe according to this, maybe they could harvest their mussel before, because if we put our model of mussel growing together with the data that we are collecting from satellite, we can say then that, okay, the size of the mussel is estimated as a good size. The price on the market for this size is this. You can see the report here. And so maybe it is convenient to harvest now the mussels. Another opportunity that we give is when there are some pollution coming from the river plume, for example. In that case, could be useful to harvest before the pollution arrives to the farm. So even if there are also historical applications that you think, okay, they don't need satellite data, but there are some new situations that ask for them. And then I want to conclude with some application about one of our bestseller service, that is Reticus displacement, where we use multi-temporal interferometry. Thanks to SAR data, we can measure from 600, 700 kilometers displacement in the order of millimeters, because we are able to measure the difference using a stack of images, let's say, at least 9 images, temporal images, in the same geometrical configuration of the satellite. The satellite is always seeing the ground, the Earth in the same configuration. we can measure the phase difference between an acquisition and the other. And consider that here we are in the microwaves, so we have a wavelength of 5 centimeters. We can measure displacement in the order of millimeters. Of course, we are not always, there is a lot of noise for the signal to go from the satellite to the Earth and to come back, but we can recognize a trend. And of course, if there is a trend, for sure, there is also a movement. Here, for example, on the left, you can see the subsidence that is real along the river Tevere in Rome. And the measures that we have in around the Tevere, we can see also from the satellite. The same could be used for road monitoring, for let's say all the of the construction made by the man. And related to that, we can have a lot of application. For example, for monitoring of pipeline networks. In this case, we are monitoring water and waste pipeline, and in order to avoid bad situation for cars like that in the picture. And so what we are going to say to our company is that, okay, if we see some pieces for some segment of the network red, maybe it is the case to inspect that segment of the network, and because maybe something is happening. So we provide information helping them in defining maintenance plans. Consider that it is a dynamic information. Normally, what they do is using only anaglyphic information, historical information. So they know, of course, that if a segment of pipe is older than the other, maybe it is more important to control that of that part of the network instead of the other. But we can even put other information. And consider, for example, that a truck passing in the city, on a road in the city, is like 20,000 cars. So if there are some roads with many trucks on them, maybe we can have a problem like that. Again, for the same reason, we can use this kind of technology to monitor segment, road segment. And in this case, you can see that something is moving, something not. Maybe it could be the movement could be natural in the sense that it is the infrastructure that is moving, or maybe it needs some further assessment in order to avoid what we have known in the last years, problem like this. Of course, I'm not saying that we can foresee the fact that a bridge will collapse or not. I'm only saying that there are some information that could be even catch from the space in order to help our the maintenance provider in understanding if they need to inspect some particular path of the road or not, and this in general, as you have seen. Okay, so we have gone from what we say remote sensing, let's say visual inspection. We know that to get it, we have to task the satellite, and in fact here you can see that the first step of Earth observation value chain is that of planning and tasking. So we ask to the satellite to do something. Then the satellite collect data, and we call this part upstream. After collecting, when there is a visibility of ground station, the data is downloaded to the Earth and is processed in its first step, and we call it midstream. Then a distributor put the different level of products on their catalog, and finally, value-added provider like Planetek, even if I told you we are all over the value chain, but in particular, Planetek is also a value-added provider, can transform the data to provide information to the user by, for example, for reticus. And this is the traditional EO value chain, and we can say the current EO value chain. So all the satellite work in this way. So even if we have a lot of satellite, thanks to the new space activities, so Planet, for example, launching 200 of CubeSat, or the other 1,000 and more of CubeSat launched by different countries and different companies. So we have a lot of data. Of course, we are linked to this kind of value chain, and of course, we have still some limitation. We have poor flexibility. The satellite must perform the task that have been uploaded to him. Has no autonomy, so the satellite must do that. And of course, this means that we can miss a lot of observation, not only because the satellite is not in possibility to work in autonomy, but even because each time we sense some information, we need to put them into the memory, and the memory is not a commodity. We need to download it to bandwidth according to the bandwidth that we have. And again, we do not have an infinite bandwidth. And we can do that only when we see the ground station. So there are a lot of possibility of observation that are not at all considered. And moreover, a lot of the considered observations, so the observations that have been tasked, maybe have poor quality or irrelevant data, and so but they are stored in the memory, and they are also downloaded, and they take place in the timing of the satellite. And so we cannot do something useful, we do something unuseful. So we thought to put together upstream, midstream, and downstream, and we call it SpaceStream, because we want that all the activity could be done in different parts of the value chain. And the subtitle of SpaceStream is that we want the right information at the right time in the right place. So I don't want unuseful information. I want only the information that I need. And not only, I don't want data as a customer, I want only the information. If I want to check if there are some oil spills, I'm not interested in seeing a very big part of the sea. I'm only interested in seeing, or better, in knowing the coordinates of the oil spill, the coordinates of the non-collaborative ship. And while sending data to the Earth means to transfer, to download something like a few gigabytes of information, to download only a coordinate, we need only, let's say, 8 bytes. So even in a situation like that is now, to these days, solar orbiter, where the bandwidth is very, very low. Solar orbiter is going with a bandwidth of 8 bits per second. So I didn't remember any modem in the past using only 8 bits per second. But because of the configuration of the satellite respect to the Earth, the only possibility that we have is to go at that speed. Even in that situation, we can transmit the information useful to understand the phenomena that we are related to. And of course, I want at the right time. I don't want to wait for 1 day, 6 days, 6 hours, because typically, if I have to go on the place where the Coast Guard needs to go on the place where there is a spill, it needs to go there when we acquire the information, because if we go there after 6 hours, maybe we don't find anymore neither the ship or the oil spill. And in the right place. In the right place, it means that in order to have a sustainable workflow, Earth observation workflow, maybe we need to extract some information on board and some information on ground, because we have to respect the complete workflow not only the last part. And so we, for example, let's imagine that with a satellite, we are able to understand that something strange is happening on the sea, no? But we cannot see very well what is happening because we are acquiring at a coarse resolution. But maybe we have some suspect. So we can do that on board, and we can task the subsequent satellite to observe that part of the sea, of the land, at a deeper resolution. So I cannot wait for downloading all the data to the Earth and then after processing upload a new task for satellite. I need to do that from satellite to satellite. Giving a definition for Planetek and also for other companies that are using this taxonomy, we intend the SpaceStream as networks of heterogeneous and distributed ground segment. It means that, and it is already a reality, the ground station cannot be totally devoted to one mission. So the ground station must be able to get information from different mission and heterogeneous mission also. And also the satellite could speak with different ground station. We have to say that today we can do that, but we cannot do that without having a plan. So we cannot transmit when we want, we need to be authorized to transmit. Moreover, it is also composed by swarms of cooperative and competitive space agents. These space agents are the satellite, or maybe also HAPS, high altitude satellite, or drones, or IoT. So there are space agents distributed at different heights that must act as a cooperative, and it is very important, but we think also as a competitive. And it means that competition is important because each satellite could acquire the information that we need with different costs, first of all, but also with different characteristics. So maybe we want to know oil spill. Okay, the difference between having an oil spill at 10 meters of resolution or 5 meters of resolution is not important for the customer. So if the cost is different, it could be a good reason for choosing one or the other space agent. Nevertheless, you are also related to the timing. So maybe it could be very important to pay a little bit more, but to be in time for the acquisition. So the competition is also an important, a new and important factor. And we strongly believe that upstream, midstream, and downstream, so from the upstream to the downstream, everything is mixed in what we call the FOD, another IT word, of the continuous, what we call continuous space stream. Everything happens in the continuous space stream. And the reason for doing that is that we want to reach the goals of responsiveness, reactivity, low latency, deep customization, and complete integration in secure and traceable environment. Now, I don't want to explain this because they will be explained after. So there are a lot of reasons for which we want to achieve the space stream. So from the edge to the central part. So we want to achieve the space stream, but can we really achieve it? Can we sustain it? Okay, we think yes, of course. And the first reason is because your data today, okay, is not a commodity, as I wrote, but is more and more a commodity. So it's a commodity because we can get the same data at different time also by different data provider. We have 2,000 or 3,000 satellites flying. And moreover, we have also some mission and constellation like Sentinel or Landsat that are totally oriented to be what we call background EO mission. They continuously monitor the same landscape, the same territory, and even Planet does the same thing. So why I'm stressing this part? Because we have said that we want to process data on board. And we want to process data on board because memory is not a commodity, because we want to save part of the memory. It means that we want to discard data. And typically in the past, the data are an important asset, an important resource that we do not want to discard. Today, we are in the condition to do that. So if we discard something on board, we can be sure that we have not lost so important information. And so we can ask for more than data. So we are going further than data. And as said before, we want to achieve the capability of the system to be responsive, to react, and to have low latency. Responsive, it means that we know what we are searching for. For example, again, always the same example, the oil spill, and just after sensing, I process the data, and if I find a spill, I'll send the coordinates to the ground. In this way, I can achieve the goal of responsiveness, in the sense that the time between sensing and the information is very low. I can do that because I can exploit other channels that are not strongly related to the ground station, but I can ask to other ground station to get information for a few bytes and not for gigabytes. Another way of acting is reactivity, in the sense that we don't know what we are searching for. So we don't know if we are searching for fire, for oil spill, for non-collaborative ships, for river plume. But if we find some anomalies in our sensing, just after sensing, I'll send the information to the Earth that something strange is happening on the territory. And so I react as a satellite, of course, and this is the reason for having proactive collaborators directly on board and not only passive workers. And I react to the data that have been sensed from the satellite to send information to the ground. Doing that, in the sense that if a data is not useful, I discard. Of course, I can be tasked as a satellite. I can be tasked with different tasks, and so I can provide more services to our customer. And so instead of waiting into a queue, the requests from our customer are immediately uploaded. So less data, but more services. Okay, to get this, of course, we want some particular characteristic in the satellite. And first of all, we cannot do that by manually. We need some machine-to-machine mechanism, because we need that all the ecosystem, all the systems are interconnected, and we cannot wait for man's deciding what to do. And another thing that, of course, we need is high-performance computing, because we want to process information. And even if on Solar Orbiter today is running a Leon based architecture computer, so something like a Pentium, the first Pentium, the Pentium at 100 megahertz, and so something can be done. Of course, if I want to put some artificial intelligence algorithms on board, I need high-performance computing. And I don't have all the energy that I have on the Earth. So energy must be a commodity, or the high-performance computing must be low power. And we see that in the next slide also. And again, if I want to transmit my information to the Earth when I sense, I need to have some channel, some telecommunication channels always on. Maybe not big channel, as we were saying, but even with a small bandwidth, but always on. Again, I need to be independent from big data, because I cannot store everything on board. So I can put indicators on board of this coming from big data. And such kind of paradigm should not be used to monitor in a recurrent way the planet, but should be used to address events that act locally in space and even time. And in fact, the next question is that, do we need that? And so, again, we think yes, because there are a lot of use cases that can exploit the space stream. And in this case, we have marine security, land. I said something about that, like oil spill or fires, flooding, but even phytoplankton bloom or plastic island. If you want to monitor marine litter, plastic litter, you have to collect continuously all the ocean, all the sea. And of course, it is most of the time it is a waste of resources because you don't see anything. But if you, and so this kind of operational concept is not feasible. It is not feasible economically, and even it is not technical feasible. But if I'm ready to discard all the information, all the data that have been sensed by the satellite, but that not contain any plastic, plastic litter, then I can sustain this mission, because even from economical point of view, I'm not using at most the onboard asset. Okay, I'm sensing, but typically on the ocean, no one wants to sense other than the ocean. And if the information is not useful, I discard it. And again, the same we can say for thermal anomalies, for Urbanite Island, for river plume anomalies, or non-collaborative ships, or accident. If I see an airplane, I cannot ask a satellite to say, okay, find all the airplanes or ships with an accident. But if I see something not usual, I can send to the Earth. And again, also for the border security, the example that we have seen for border security, the satellite was tasked after the fact that we knew that there were some migrants on the border. And so we want to understand what was the situation. Or even, for example, let's suppose that China was building hospitals before saying to the words of the new coronavirus. Of course, we were not aware of the fact that there was a virus, but if we had some satellites catching these anomalies from the Earth, maybe we can understand before what was happening. So, in order to let you understand better what is the space stream, I want to do this example and simulate, or better compare, the space value chain to the food value chain for human digestive system. Here you can see a body with the mood, food pipe, stomach, and so on. And typically, after putting food in the mood, you download it by the food pipe to the other organs. So we think that this is the value chain, the food value chain. But really, before downloading, one of the first activity that we do before eating is to see our food, because even seeing that, we can recognize if it is good or not for us, and so we can touch to understand the consistency of the food. So smell, taste, and even we start before downloading, we start pre-processing. It's like the pre-processing that we do on board of satellite, thanks to saliva, thanks to chewing. And we can even use external sensor like scales for the quantity, or like clock for the timing, or a knife for selecting what we want to download. And so we can say that this is the part of the upstream that need to manage and process and recognize the food on board before downloading. Then it is downloaded, is processed in the midstream, and maybe we can think also of two different kind of downstream services. One is for waste, while the other one is for energy. And this is a very good comparison between what we want happening on satellite and what is made by the food value chain. So we put some brain, tongue, and knife on IO, which is the deployer of our company friend company, the Orbit, and we launched the program AI Express together with ICO, another Italian company. Also, the Orbit is an Italian company, and thanks to the co-funding of ESA by means of incubed activity, we started the implementation of the concept of the SpaceStream. We started this project at the beginning of this year. We have it in mind from 2 years or 3 at most, at least. And finally, we are in these days for 1.5 years in the path of developing the solution. So we have not yet a flying solution for our Spacedge. We are developing it, and I will show you also some opportunity of collaboration. It is a totally Italian consortium now. And by AI Express, we want to create, as I was saying before, a space ecosystem developed as a service. So on board of AI Express, AI stands for artificial intelligence. We have put some specific components that are able to load and run some space application directly on satellite, and these components are able also to manage all the resources, hardware resources that are on board of the satellite, like memory, like CPU, like sensors, like bus, and all these resources are managed in a Uberized way, in the sense that they put their availability to the system when they have the possibility to perform a job. On the Earth, there is also the Space App Stores that is able to virtualize the hardware, in the sense that thanks to these app stores, we can run this kind of application on different hardware and on different sensors that could be embarked on the ION platform, or even on board of heterogeneous platform, as we are going to see. So what is the value proposition of this program AI Express? We want to make possible the configuration of new artificial intelligence, and we are speaking about convolutional or deep neural network, and we want to configure new artificial intelligence network on the ground and to make them available on board. We want to make possible the usage of all the functionality exposed by the assets on the satellite to be used by the different application. It means that thanks to that, we can configure new mission concept on demand. Each customer can decide how to process his information, how to use the sensed information. And so it becomes also a in-orbit demonstration environment where the developer, the innovators, can start in testing their solution to understand if it could be achievable, it could be sustainable. And it means that we can perform an experiment. And finally, we can see further, we want to transform customers, stakeholders, providers in shareholders. So all the stakeholders could even be part of the revenue share. So again, if you are an Earth observation algorithm developer or yes, let's say service developer, you can put it on board, you can use it at the Spacedge, and you can use all the hardware and software resources. And you can understand if it is good or not. Or if you are only a hardware and software space component developer, you are not interested in application, you can put your asset on board, you can perform what we call in-orbit validation to understand if your technology works on board of satellite. And after that, you can even be part of the ecosystem, becoming a shareholder, but you could also become a shareholder of the IX ecosystem by embarking part of the AIExpress technology on your satellite, and so you become another actor of this of the AIX ecosystem, and the glue between the different and the heterogeneous satellite is guaranteed by the App Store, so that an application could be run on any of the satellites and according to the needs of the customers, of the user. So again, what happens? A user could choose, configure and activate the space application on ground, the space from the App Store, that want to run on board of AIExpress. Then it is a schedule, of course, assessed, checked, and thanks to the ground station, is uploaded to the satellite. The AIX onboard computer decide how to deploy it and which should be the asset to be used by the application according to the needs of the application, like the payload, the memory, the bandwidth, and so on. And then there is the phase in which the data are acquired, are transformed in actionable, in analytics, and then are transmitted to the Earth in the form of wisdom, in the sense that thanks to this transformation, the customer, could have the right information to act, and without taking care of the data that have been acquired. In a different way, we can see a scheme like this, where we have in the left part some of the services that are provided by the satellite, like also, of course, basic services like time, attitude, position, computing, propulsion, the different sensors that can be embarked on the AIExpress, and different functions that guarantee the usage of different these different sensors. So what happened? The user use some of the function that can be off board, so on ground or on board, already on board, create its his workflow, start his mission, let's say, upload the what we call contract, but upload his workflow, and after uploading, it is executed by AIExpress framework. We call it contract because one of the main pillars of the AIExpress is the usage of blockchain technology, in the sense that thanks to the blockchain technology, as you remember, we can ensure the tracking of the transaction. We can ensure the exposition of smart contracts, so that each asset and each functionality can expose its smart contract, could go even in competition with other smart contracts, and can be executed according to the needs and to the workflow that we have uploaded. So what are the components? We have on board, of course, an AIX box. It is made of high-performance computing. There is all the software that we are developing, and there are also stored some libraries for like standard imaging libraries or artificial intelligence libraries, and it guarantees also the usage of the blockchain technology. So this is a box that include all the infrastructure functionality of AIExpress. As I was saying before, this box can be embarked even on board of other satellites. In this way, it becomes part of the ecosystem and of the constellation of AIExpress. For what regards only to show you some technical features, for what regards the onboard computing, we performed our first trade-offs, and I think also final, for the technology to be used. Of course, to understand what to use, we put some key performance indicator and this is a synthesis of the work we perform. And for example, of course we want a computer with a lot of capability in terms of computing, of processing, that use no power, that is free, and that is always very reliable. And the choice was done, and it is that of a micro-semi-polar fire system on chip. Then on board of it, we need to install a real-time operative system. There are a lot of real-time operative system on solar orbiter. Currently, we are using VxWorks. On other satellite, it is used RTEMS, you can see here. And but we went to choose FreeRTOS. Of course, we would like to have an operative system with no memory footprint, because we don't want to waste memory, but we choose one with the biggest memory footprint, with an architecture, RISC-V architecture, with no license cost, and with a good certification and heritage in space. Of course, as you can see, when you perform trade-offs, all of these characteristics are always in contrast each other, so you cannot have everything. Just because now I don't. Okay. So thanks to this choice, currently we have a software architecture like this. The bottom part is the hardware part based on PolarFire, and it guarantees 4 CPU, guarantee also the access to the hardware resources of the satellite, thanks to power, CAN bus, and so on. And on top of this microkernel, we have installed FreeRTOS, and some of the software is, of course, that of what I call the infrastructure of AI Express, while other software is used from, will be used better by the user with the ease workflow. So with this job, and we can see both functionality relating to imaging, because we are speaking of imaging in general of signal, or some functionality not related to imaging. So this is the organization that we have designed until today. On board, we need to find, of course, also sensors. And as I was saying before, we can host different sensors, even provided by third-party contributing sensors, because let's imagine a company who is developing a multispectral sensor and wants to test it.
We are going very long. Can you shortly close your presentation?
Yeah. I think that, I don't know, Marco, what do you think about that?
Cristoforo, it depends on you. If you want, we can go ahead and maybe avoid questions in order to be in time, as you want.
Okay, I need at least 10 minutes to.
Okay. In any case, you can finish, and then maybe just few questions if there are.
Okay.
Okay.
So we have the possibility to embark different sensors, and for the first flight, we are going to embark Sentinel-2-like sensors for this first flight. As said, there are some onboard services that are provided to the users, and finally an app store, where some users could act as a customer, they can buy, and some other can act as developers, so they can develop application and deploy on the App Store, and finally they would be deployed on board. Among the services, some of the most important are those related to the monitoring, so change and noise detection, to the standard image processing or neural network library. For example, here, after getting information, if you want to understand where is the ship, you have recognized the ship, but you need to say to the Earth, where is the ship? So First, you need to delete all the cloud, and then you need to understand what is the attitude of the satellite and its position on the orbit. And only after registering the different band, for example, acquired, you can send to the Earth an information representing the coordinates of the ship. For what regards the artificial intelligence algorithms, of course, we strongly think that we have to prepare data and to define neural network on the ground, and only after we have to upload them on board and to use it. In order to let you develop new solution, we are going also to develop a development kit, so that we can provide to you the complete software tool chain, the hardware, what we call also flat satellite, and all the tools that are useful to validate and simulate your solution. Moreover, for what regards artificial intelligence, you can use your favorite machine learning framework, and thanks to the TBM interface and knowledge exchangeable knowledge information, we can upload them on board of AI Express. Here are some examples. For example, cloud detection. It is already flying, and we can detect on board if there are or not clouds in order to discard or not the seed that have been acquired, ship detection, as I was saying, or even super resolution. So even by using a stack of images, or by using a single image and exploiting the knowledge coming from the dataset used for the neural network training. And last, missions like this could not be achievable without processing on board, because if we want to detect debris or NEO by using the sensor embarked on the satellite, we need to get an information every 1.5 seconds. It means more than 20 gigabytes per orbit, and we are not able to download it. While if we process, and it is feasible because the process of USB image can be done in 1 second, we arrived to a total information that is 400 times lesser. So we think that by Spacedge and AI Express, we can reshape, rediscover, as the title of these webinars, the space value chain, because we can demonstrate early in orbit our concept. We can even learn by failure, and we can implement new end-to-end application. Well, finally, I have to say that Spacedge is the sum of the business provided by Reticus and the technical capabilities provided by AI Express. So, of course, we don't want to develop only technology. We want to make business, and we think that this solution will have a very, very flourished future. I want to conclude with some engagement opportunity. I know that I'm speaking to PhD students, so I think that these kind of opportunities could be very important also for you, young, motivated, and smart people. And for example, there is a lot of technology that needs to be developed to address this new kind of operational concept. In red, you can see something that we are just doing, but there are also other technologies that need to be developed, and you can concentrate on it in your study, your research, to understand how they could be used even in a space context, or directly using AI Express. You could develop your application, or you can develop your hardware, and we could try to use it on board directly of AI Express. Our maiden fly is foreseen for the fourth quarter of 2022. We want to anticipate it to June. We are in negotiation now, but in the next year we will have our first flight. And I want to thank you for your attention.
Thank you very much, Cristoforo, for your inspiring and very interesting talk. And I would have a lot of questions to raise, but there is not a lot of time left. So just a few considerations. You are developing what can be considered, for example, an IoT network in the space.
Exactly. Exactly.
IoT network in the space to collect the data for each customer that is interested to see some specific aspect on the Earth.
And to transform that in information before arriving to the Earth, because differently from the IoT network on ground, where the bandwidth, we can say that is a commodity, even on ground, is not always a commodity, of course.
Yes,
if we are in the desert, is not a commodity, but especially in the hardware, is always not a commodity. So we need to perform some operation before centralizing data, and we need to lost the data. And I think that I give you the reason for which we can allow this loss.
So currently, what are the biggest challenges you face to completely implement a Spacedge architecture?
Well, for sure, the energy, in the sense that the more powerful is our computer, the more energy power we need, and there are a lot of resources that are in competition for having energy from space, and moreover, if we can get them in low Earth orbit satellites, more the sun is far from the satellite, less energy we have. And so we need to have, and there are also some research already, for example, low power GPU. And Myriad from Intel, for example, uses 1 watt of power to perform operation using neural networks. So there are some solutions, but it is also expensive in terms of power. And moreover, we need to start, because this kind of operation today are not made at all. No one uses satellite to perform some processing step on board, except science, because they must do. And it is very strange, because at the beginning, I think that in 2013, we started thinking about, 11, we started thinking about processing data on board. And we believe that scientists want always all the data, even the noise. And they don't care if the data are noisy or not. They want everything, because they don't understand. But they are obliged to discard data, because they cannot download. So we found the solution in a field where we didn't think to find.
Thank you very much again. I think that this webinar can be concluded, and I ask Marco to say yes.
Dino, there is a question from
okay.
Greg Cipollone. Just a second. Okay, now he can talk. Greg Cipollone, you can ask your question.
Hi, thanks for that. I wasn't expecting to be on live. Question for Cristoforo. Thanks a lot, by the way. Very interesting presentation. You mentioned the challenges of increasing electrical power and also computing power, but how do you see thermal control as an issue in actually generating more electrical power and the need for more computing power?
Yeah, for sure. Yeah, for sure. We have to improve all the systems, subsystems that are embarked on board. I have to say that typically Planetek is not involved in this kind of trade-offs and this kind of activities. So, Greg, we have a system vision. We know where the problem could be. Nevertheless, we do not take care. We can only ask to our partner to take care of that. And for sure, the thermal control is one of the biggest problems that normally you have on satellite, even because in general, the capability of an asset to work in space is made by qualifying that components in space. Today, by using more and more customer of the shelf components, typically they are not developed and built for being used in space. And so every time we have to discover if they can be used or not. And this is also the reason for having in-orbit demonstration or validation activities. But for sure, all the hardware could have some problem for this big usage of its resources, even the memory for storing and discarding and resetting and so on.
Thank you.
Thank you, Craig.
Any other question?
I have a curiosity, if I can.
Of course you can.
Yeah, the last, let's say. So, Cristoforo, my curiosity is if are there any application of the satellite services like the one you showed for managing the COVID pandemic? I don't know, for example, monitoring movements or transportations during the lockdown. I'm really curious about that.
Yeah, there was also a big effort made by Italian Space Agency in trying to find how the space technologies could help the people during COVID. And I have to say that the most of the contribution is related to telecommunication, of course. It is also the most mature market in space. And so there are a lot of applications that could exploit the telecommunication satellite or navigation satellite, of course, that are always together. For what regards Earth observation, of course, we can map the situation. And we can try to characterize to develop some thematic maps about what is happening on the Earth. I have to say that, as I was saying before, the satellites, the Earth observation, especially the Earth observation satellites, look the Earth only at some specific timing. It means 11 o'clock or 2 p.m. o'clock. And so you cannot have a good monitoring of the situation. You can also assess what is the situation, but you cannot control continuously. While by means of telecommunication and GNSS, you can have a continuous stream of information. So what we proposed was to use the Earth observation to understand or to be sure that the fact that the people was not going to work, especially in poor countries, was not a problem, would be not a problem for food security. And so use Earth observation to understand if the wheat, maize, rice still were following their growing, even in a pandemic situation. And it was the only application in which we think that Earth observation could provide a very big contribution, because no one could go on the field also. So you could use this kind of monitoring.
Okay, thank you.
You're welcome.
I see that there are no more questions. Dino, I think we can close here. If you want, I can say something. So, Cristoforo,
Of course.
I really appreciated your clear and very interesting talk. I really liked it. So this contribution from experts in different fields, as you say, they are very important for our PhD students. Also, thanks for showing the expertise you need and the expertise you expect to need in the next day. So thanks for sharing your experience with us and for your time. We abused time today.
It was a pleasure for me.
Of course, your presence here would have been a plus, but I'm sure this would happen soon. So I will contact you again
Okay, thank you.
soon. Thanks, Dino, and thanks everybody for participating. So I
Thank
think
you
we can...
all.
Thank you again. Thank you again, Marco.
Bye-bye.
Cristoforo.
Bye.
Bye-bye.